Hi, I want to introduce you to Elusive Data's new SQLite Varint Calculator for iOS. It's a new app that we just launched on Apple's App Store, and I think you're going to want to start using it right away in your app investigations. To demonstrate how it works, I've selected a page in an SQLite database that contains records from a contacts table. Varint Calculator has the ability to not only convert varints to their integer values, but also identify the length of strings and blobs from varints within record headers. And as a bonus, it also lets you know if the cell you're working with needs overflow, and if so, how much of the cell's payload can be found on the local page, leading you directly to the first overflow pointer. I've already highlighted the record we'll be working with so I can visually demonstrate the calculation of the values in the cell length indicator and the record header. The first two bytes, A347, that is the record length indicator. I'll use the Varint calculator to convert those bytes to the actual length of the cell. As I start typing in the values into the Varint calculator, notice the immediate feedback. First, it's letting me know I haven't actually typed in a complete byte since I've only typed the first nibble. And after I enter the first byte, it is automatically telling me I'm not done. It sees that the first byte indicates that there is more to this varint since the most significant bit is in the on position. Once I enter the second byte, it knows that this is the end of the varint and displays the converted values. In this case, it tells me that the cell is 4,551 bytes in length. Now, the page size in this database is set to 4,096 bytes, which means this record is too big to fit on this page and there must be overflow. But how much of this record can be found on this page? Well, if we scroll down in the results window of the Varint calculator, we can see that it displays that there is overflow, using a default page size of 4,096 bytes, and that 489 bytes of this record is found here in the local storage. But what if we are working with a database that has a different page size? If you look under the current page size, there is a note to long press to change it. And with the long press, we can see other page sizes to choose from. But we can verify the local page size by highlighting from the start of the record header 489 bytes, which takes us directly to the pointer to the overflow page, hex 0C, which is page 12. Next, we can use the Varint calculator to help us convert the serial types found in the record header to their correct string and blob lengths, as well as tell us what the single byte Varint values are. The header is this 8-byte set of hex values here. The first byte just tells us how long the header is. The next byte, being 00, takes on the row ID, which is 5. But the next value is hex 02. Punching that into the Varint calculator tells us that when reading this as a serial type, we read 16 bits of payload, which is 2 bytes, as a signed integer. Next is hex 19, or hex 19. Typing 19 into the Varint calculator tells us that this serial type is a string that is 6 bytes in length. And as you can see, that is the first name, Sophia. The next two varints are also string values. Hex 17 is a 5-byte string for the last name Reyes, and hex 2F is 17 bytes for the phone number. And finally, the last 2 bytes in the header is a 2-byte varint. Again, as I type those values into the Varint calculator, C6, it prompts me to continue to the next byte, 4E, and gives me immediate feedback that this is a 4,513 byte blob, part of which can be found on this page, but the rest can be found on page 12. Thank you for watching. The Varint calculator is available now on Apple's App Store. Download it today and see how much faster and clearer your SQLite analysis can be.